Before a single piece of steel could be lifted, engineers faced a canyon so deep.
This was Huajiang Grand Canyon, one of the most challenging landscapes in all of China.
Every measurement had to be exact, mapping the geology and identifying locations for the towers. Months of planning confirmed rock stability, ensuring the foundation could support the enormous bridge structures.
Long before the bridge took shape, crews first had to build the infrastructure needed to construct it. Temporary mountain roads became the lifeline for every worker and every ton of material that followed. The cliffs themselves became part of the engineering solution, supporting the foundation of the massive bridge.
Reinforced slope protection transformed the mountainsides into foundations capable of supporting one of the world's tallest bridges.
Reaching solid bedrock was essential to carry the enormous forces once the suspension system was complete.
Every meter of excavation brought engineers closer to the stable ground required for this project. Steel reinforcement transformed excavated rock into the structural backbone of the future bridge towers. Every bar was positioned to strict engineering tolerances before concrete could lock the system together. Concrete placement was a precise operation, ensuring each section cured as a single structural mass. The foundation was designed to transfer enormous loads deep into the mountain rock itself. Construction paused only on the surface, while engineers verified alignment and structural quality for the towers. Dimensions and structural strength were confirmed before allowing the next phase to begin.
With foundations complete, the bridge finally began to rise above the deep canyon floor. These towers would carry the heavy suspension cables needed for the entire crossing. Each new concrete lift brought the towers closer to their final height above the canyon. Only after these vertical structures were complete could engineers begin stretching cables across the gap.
This ground-to-air shot reveals the sheer scale of the operation as the segment is slowly raised into position.
Each reinforcing bar had a structural purpose, creating the skeleton that would resist enormous compression forces. Concrete quality was paramount, compacted and cured under carefully controlled conditions for every vertical section.
Constant surveying ensured that every new section remained aligned with the bridge's complex final geometry.
As the towers climbed, logistics became difficult, requiring precise crane coordination high above the floor. Weeks turned into months as the towers gradually reached their designed elevation above the canyon. The tower head became the critical transition point, transferring thousands of tons of load safely. Before the first cable could cross, every support surface had to be positioned with extraordinary precision. The towers now stood ready, providing the vertical backbone needed for the bridge's next phase. For the first time, both sides were connected by engineering preparation, ready for the impossible gap. The first connection wasn't a massive cable, but a lightweight rope, guiding the path ahead. Correct tension was essential, as it dictated the accuracy of every construction stage that followed. Progressively heavier ropes followed, preparing the canyon for structures capable of supporting workers and equipment. Engineers built highways in the sky, allowing crews to work safely above the deep canyon. Every step took place hundreds of meters above the river, forming a temporary, suspended workplace.
With the catwalk complete, crews prepared for the defining operation of building massive suspension cables. These cables were assembled one wire at a time, forming the strength required for the span.
Repeated thousands of times, This simple process created the strongest elements of the entire bridge. Precision compaction eliminated gaps, ensuring that every strand shared the enormous bridge load equally. The bridge now possessed its true backbone, ready to support the hangars and the steel deck. Suspenders were installed to transfer the weight of the deck into the massive cables above. Each suspender transformed the system, preparing the bridge for its heaviest construction phase, the deck. Every connection had to perform as designed, ensuring the bridge deck would remain perfectly balanced. Now the first steel deck segment arrived, ready to leave the ground for the very first time. Every lifting point was checked repeatedly, because there was no room for error in this operation. The first segment rose slowly, controlled carefully to maintain stability high above the canyon. Positioning required remarkable precision before it could become part of the permanent structure. Temporary connections allowed the segment to carry weight while preparing for the next section.
Construction advanced from both sides to keep the suspension system balanced during every step.
Piece by piece, the bridge stretched across the canyon, becoming one continuous structure. Months of balanced construction brought both halves of the bridge within sight of each other. This final segment demanded precision, as it would permanently connect both sides of the suspension bridge. There was only one opportunity to fit perfectly, as the steel approached the center. Now the first steel deck segment arrived, ready to leave the ground for the very first time.
Steel from both sides met in the middle, finally forming one continuous structural system. Temporary bolts secured the joint, allowing verification of the load before permanent fastening.
Permanent connections transformed segments into a structural system capable of carrying traffic for decades. Completion was only the beginning, confirming that every cable and connection worked together. Temporary structures disappeared, revealing the bridge as it had been designed. The gap had disappeared. It was time for the final work to transform a site into a highway. Construction had ended, but every critical system had to prove it could perform as designed. Modern bridges monitor themselves, measuring vibration, temperature, and behavior long before problems become visible. Calibration ensured that the monitoring system would remain accurate for the bridge's service life. Load testing would confirm if the bridge behaved exactly as the models had predicted. Engineers recreated extreme loading conditions, using dozens of vehicles across the entire span.
Measuring subtle changes confirmed that the structure was behaving exactly as intended under load.
Engineers also measured response to moving traffic and the dynamic forces generated during operation. Confidence in the bridge grew as real measurements aligned with original engineering models. After years of planning, construction, and testing, every major milestone was successfully completed. This impossible gap had become a permanent connection, ready for its true purpose. This bridge changed how people move, replacing long detours with a quick, safe crossing.
Designed for generations, every detail handles traffic and forces of nature for the long term.
Rising hundreds of meters high, it is a monument to human determination and ingenuity.
If you enjoyed this construction story, Subscribe for more unbelievable engineering feats from around the world.